with ratios, guys? Okay. So we spoke a bit about ratios in one of our other lessons. So I thought we should just have a proper lesson to do with ratios. So here goes, okay? A ratio is a way of comparing two or more similar quantities, not qualities, okay? Now, similar means they have to be in the same unit. That's what we mean over here. So if it's a ratio, it will always have the same unit. Okay, so they can be used to compare a lot of different quantities. And let's look at our example. Suppose we have a model boat. That's one of those small boats. Okay, I'm going to restrict muting to avoid what just happened now. There we go. Suppose we have a model boat. That's one of those small boats that show you what the actual big boat looks like. And the length of this boat is 1 meter. So this small boat is 1 meter long. So it's not necessarily this small. Maybe it's like that small. Okay. Whereas the actual boat that this model is representing is 25 meters long. Now, if we were going to write this as a ratio, you're going to write the 1, the 25 with a colon in the middle there. That is a ratio, okay? Now, take note, there are no units in the ratio because we are assuming that these two are in the same unit. So if you have a unit of the model, you will use the same one for the actual boat. That's how ratios work. Okay. Now, the second most important thing that we're going to talk about is simplification of ratios. Every time you have a ratio, always simplify. Always simplify it, okay? I'm going to show you now what I'm talking about. Now, if you speak about a ratio, okay, a ratio does not necessarily tell you exactly how much of something we have. Let's look at an example. Now, to make pastry for apple pie, we need 4 ounces of flour and 2 ounces of fat. So the ratio is 4 to 2, but I just told you now you need to simplify it, right? And the way to simplify that is you're going to look at the highest common factor. So the highest common factor between 4 and 2 would be 2. So you're going to divide both of them by 2, which means your ratio is 2 to 1. This is the final ratio over here, right? That ratio does not mean that you're going to use 2 ounces of flour and 1 ounce of fat. It is just a ratio. It's saying basically for every 2 ounces of flour you use, you are going to use 1 ounce of fat. Do you guys understand what I mean? So ratio is actually telling you about a relationship between stuff. It's not telling you the exact amount. So I'm going to write that on the side here so you guys do not forget. Ratio tells you relationship and not amount. Okay. So it does not necessarily mean you will use exactly that. For instance, if I say I'm going to share sweets between my brother and I in the ratio 1 to 2. That's my ratio, right? So 1 is for my brother and the 2 is for me. Okay? That means if he has 2 sweets, how many will I have? If we're sharing our sweets in this ratio, if my brother has 2 sweets, then I will have how many? What do you guys think? I've given you a ratio here. We're sharing them in the ratio 1 to 2. Thank you. So if he has 2 sweets, then I will have 4. So if he has 20 sweets, then I will have how many? I will have 40 sweets. Do you see what I mean by say it represents a relationship? It doesn't tell you exactly how many sweets we have. It's just saying this is how we are dividing our sweets. All right. Great. So if you have a ratio, always simplify it, but always remember that it is not the amount, it is just the relationship. Now, if you're given a ratio as a fraction. We do not want fractions and we do not want decimals in a ratio. Okay, I'll show you just now how we solve decimals. But let's look at the fraction here. Okay, I have 1 over 4 to 5 over 8. Now, we don't want these fractions, so the first thing we're going to do is we're going to give them the same denominator. Okay, so I'm going to take this 1 over 4 and I'm going to change it to a fraction that is equivalent, but that has a denominator of 8. So that's how we ended up with, these fractions are very tiny. Let me do this. That's how we ended up with 2 over 8 to 5 over 8. And once you have that same denominator, you can quite literally just get rid of it, and your numerators will be the ratio. Okay, and then if we're dealing with decimals, remember, no fractions or decimals in a ratio. So no fractions or decimals. So this was actually part of our whole numbers chapter. Okay, so if I have, let's say 2,5 to 4, I have a problem with that decimal. How am I going to change this decimal into a whole number? Think of what we were doing with scientific notation. What can I multiply that 2,5 by to make it a whole number? Anyone have an idea? By 10. Beautiful. Senyane. So you're going to take 2,5, you're going to multiply it by 10. But in order to not change this ratio, what you do on the left-hand side, you're going to go do on the right-hand side. Okay, so times 10 times 10. So then my ratio is actually 25 to 40. Then from here, you continue, you look for the highest common factor, which in this case is 5. And then my ratio is going to be 5 to 8. Okay, guys, are you guys with me? I know I said a lot of stuff now. I have given you a lot of information. So I think what we need to do is practice a little bit and see if we actually understand what I was talking about. Okay, first one says express these ratios in their simplest form, which is what we're expected to do all the time. So let's practice doing that. The first one is 2 to 10. That's how you read ratios, by the way, something to something. My pen is very thin. I can barely see it. So I'm going to do like so. There you go. 2 to 10. What's my common factor between 2 and 10? 2. So I'm going to divide these both by 2. So then my new ratio is what? After I've divided them by 2, nice. 1 to 5. Number B says 80 to 20. What's my common factor? My common factor is 20. Thank you. If I divide both of these by 20, what is my new ratio going to be? 4 to 1. Okay. It's all right, Lali. Welcome. We're doing ratios. And the last one, I have a fraction. So it's a third to 1. That is correct. Arian, that is correct. But we need to get there properly. First, we're going to have to write this 1 as a fraction. How can I rewrite 1 as a fraction? What is 1 as a fraction? 1 over 1. Thank you. So I have a third to 1 over 1. And now we have a problem because our denominators are not the same. What denominator are we going to use here to make these two denominators the same? We have a 3 and we have a 1. Which denominator are we going to use? We can't use 1 because how are we going to get 3 to 1? We're going to use a 3, which means we must multiply this by 3. But what I do at the bottom, I must go do at the top. Okay? So then I'm going to have 1 over 3 to 3 over 3. And once we have my denominators again, what did I say we can do with these denominators that are the same? We have gotten our denominators to be the same. Thank you. We can just take them out, get rid of them. So that means my ratio is indeed 1 to 3. Yes, Londeka. Okay, so first thumbs up, thumbs down for the day. Do we understand what we have done so far? I know there were a lot of explanations, but this practice that we've done so far, do we understand it? I only have 4 thumbs up. Okay, I'm just going to go ahead and assume everyone else is fine. That's better. Oh yeah, Charlie, I understand. Okay, but we're gonna simplify a little bit more, okay? Charlie, let's see if you can catch up. We're just doing ratios. So we put numbers in a ratio and then we simplify them. So step 1, we're gonna put them in a ratio. It says in a class, there are 15 girls and 12 boys. What is the ratio of girls to boys? First, I'm gonna put the numbers as they are in a ratio. So I'm gonna put 15 to 12. Okay, now what is my common factor between 15 and 12? 3. That means I'm going to go and divide both of them by 3. Okay, so then my ratio is 5 to 4. Now, Charlie, you might be confused about why we're doing this. That is because the ratio just shows a relationship, okay? So this is basically saying for every 5 girls, there are 4 boys. It doesn't necessarily mean there are 5 girls and 4 boys. It just says for every 5 girls that you have, there are 4 boys. So if this class had 10 girls, then it would have 8 boys. Do you see what we mean? But in this case, we know there's 15 girls, so there are 12 boys. That's what a ratio is. Just shows you a relationship between 2 quantities. Okay. Next one, Johan walks 2 kilometers to school and Tabang walks 800 meters. Express the ratio of Johan's distance to Tabang's distance as a ratio in its simplest form. Now we have a problem. Before we can do this ratio, what is the problem with these 2 numbers that I have here? Units are different. We have a problem with this. We have kilometers there and we have meters over there. Okay, I'm going to leave my meters the way they are. How do I convert kilometers to meters? How do I convert kilometers to meters? Are you sure? Are you sure? We need to have a lesson on conversions, guys. There we go. Times 1,000, guys. Kilo means 1,000. So you say 2 times 1,000. And that's going to give us 2,000 meters. Wonderful. Now let's put them in a ratio. So it says express the ratio of Johan's distance to Tabang's distance. You have to write them in the correct order. So Johan's distance to Tabang's distance. And remember, in a ratio, no units. We never put units in a ratio. All right. Now let's look for our highest common factor here. What is our highest common factor here? Highest common factor is 200. Nice. Divided by 200, divided by 200. What is 2,000 divided by 200? There's actually a bigger common factor, but it's fine. And what is 800 divided by 200? 4. Do we still have a common factor here? Yes, 2. Remember, we can divide both 10 and 4 by 2. So then my final ratio is, excuse me, 5 to 2. That's correct. Nice, guys. Beautiful. So if you do not use the highest common factor, it's not a train smash. You're just going to have an additional step. So you're going to have one more step where you have to simplify it again. Okay. Now let's do these quick, since we all understand now how to do them. Number one, what is my highest common factor? 18 to 12. The highest is, thanks Rolivua, it's 6. So then my ratio is? What's my ratio? 3 to 2. Great. Number two, 24 to 32. What is my ratio? My highest common factor? Excuse me, my highest common factor? 24 and 32. It's not 10. 8. Nice. Okay, 24 divided by 8 is 3. And 32 divided by 8, it's 4. 3 to 4. Okay, I'm going to skip to number 5. We have 9 to 15 to 21. What is the number that goes into all three of them? 3. It is 3. So I'm going to divide all of these by 3. And then my ratio, 9 divided by 3 is? Nice. It's 3 to 5 to 7. Beautiful. Now let's look at number 7. What problem do we have there by number 7? What's the problem with number 7? There's a decimal. Now let's get rid of that decimal. How are we going to get rid of that decimal? We're going to times 1,6 by 10. And that's going to give us what? 16. But what we do on the left, we have to go do on the right. So then I also have to say 1 times 10, which will give me 10. So then the ratio is 16 to 10. Is there a common factor between 16 and 10? It is 2 divided by 2. So then my final ratio is what? 8 to 5. Beautiful. Number 8. 0,36 to 0,06. Is timesing by 10 going to solve my problem here? By times by 10, no. So what do I have to times by? Nice, Tlali, 100, okay? So 0,36, if I times them both by 100, what's 0,36 going to be? 36 to what? 36 to? Nice, to 6. Now, what's my common factor between 36 and 6? It is 6. So divide by 6, divide by 6. So my ratio is 6 to 1. Let's do the last one, number 9. 0,01 to 0, comma. Let's see, 1, 2, 3, 4, 5. 1. What do I have to times by here to make sure we have whole numbers on both sides? 100,000, says Ashley. I think Kelly is saying the same thing. My eyes are just not working very well. So 100,000 is true. So 0,01 times 1, 0, 0, 0, 0, 0, and 0,00001 times 1, 0, 0, 0, 0, 0. I'm getting dizzy with all of these zeros. The first one is going to be how much? What's 0,01 times 100,000? It's going to be 1,000. Yes, it is 1,000. And the next one is going to be 1. Thanks, Senyani. So then my ratio is 1,000 to 1. Nice, guys. Thumbs up. Thumbs down. How did you guys feel about the last few that we did now? Nice. Okay, I see some thumbs up, so that's great. Now we're going to do something different. Okay, now we're going to share in a ratio. So what this means is we get given a ratio, we get given another quantity, and we have to divide this quantity using our ratio. Okay, now let's look at this example. Are those pounds? I think that's pounds. I hope those are pounds. I'm pretty sure this is pounds. So Mrs. Sharp and Mr. West share an inheritance of 64,000 pounds in euros. What does pounds look like, guys? Isn't this euros and this pounds? It's fine. That number, okay? So they share that in the ratio 5 to 3. How much do they each get? Now they have started the solution here for us. They've started the solution, okay? So I want us to look at our little egg over here. All right. So this is figuratively the whole inheritance, okay? And it's going to be split into two parts. One part of it is 5, and the other part is 3, because Mrs. Sharp, excuse me, has to get 5 parts, and West has to get 3 parts. So in total, what is it worth? How is it worth? If one part of it is 5 and one part is 3, then all of it is 8. Do you guys understand why we are adding here? I know you guys know this method, but you guys need to understand why we do it. So in total, there are 8 parts. In this 64,000, there are 8 parts, okay? Khalid, do you want to unmute? Oh, Gonji, you can't unmute anymore. Let me unmute you. There we go. Khalid, are you there?
Yes, ma'am.
Okay, Khalid, let's explain to you now.
Yes, ma'am.
I'm taking, I'm going to do this. Don't mind what I'm doing, but just look at my example, ne? Okay. Now I'm going to divide this chocolate in the ratio 1 to 2. Let me say it like that, ne? Okay. So these are telling you a relationship, isn't it? Do you agree?
Yes, ma'am.
So for every one part that, let's say, I am getting, you are going to get 2 parts. You agree?
Yes, ma'am.
So after we share it, in total, how many parts are there between both of us?
3.
3. Are you with me? That
No,
means
ma'am.
that there were 3 parts. Do you understand? Because for every one I'm going to get, this is me, I'm going to get this one, the yellow one, and you're going to get the 2. So in total, there has to be 3 parts to share in the first place. Do you agree?
Yes, ma'am.
There we go. So now what I'm saying is if I have another chocolate now here, I have another chocolate. Again, out of this, you're going to get the 2 parts, and I'm still going to get the 1 part if this highlighter can cooperate, right? So then in
Yes.
total, how much did I get?
You got 1 out of 3.
1 out of 3, right? But out of 6, because I've added another chocolate now here.
You got 2 out of 6.
2. And you got 4, isn't it?
Yes.
And how did we do that? We had to add these parts up. Do you see? So in
Yes.
total, there are 3 parts. So no matter what we get, the first thing we're going to do is divide them into 3 parts. Do you agree?
Yes.
So that once we have divided everything into 3 parts, I take 1, you take 2. I take 1, you take 2. Are you with me?
Yes, ma'am.
So now do you understand this sharp and west thing?
Yes, ma'am.
Wonderful.
Thank you.
You're welcome. Okay, guys, so I hope you guys all understand. All right, so if sharp takes 5, west takes 3, but there has to be 8 of them in total. All right? Wonderful. So now let's go from here. Now I want to know how much one part is worth. Okay, so I know all of the 8 is worth 64,000 pounds, but I now want to know what one part is worth. How am I going to do that? No. Listen to the question, guys. Thank you. I'm going to divide the 64,000 by 8. Okay? I'm going to divide the 64,000 by 8 because that's going to tell me how much one part is worth. And what is 64,000 divided by 8? 8,000 pounds. This will represent one part. Now, how many parts does shop get? 5. So that means shop will have to get 5 times 8,000, which is 40,000. Thank you. And then West will have to get 3 times that 8,000, which is 24,000. And if you add those up, those will go back to 64,000, and we have successfully divided this money. Okay, I'm going to go back to the other method just now. So someone posted a different method. Londeka, I'll be back to your method just now. But everyone who was not quite sure about dividing in ratios, how are we feeling now? Can we have a general thumbs up, thumbs down about what I just did? It's okay to know the methods, but we need to know why they work that way. Okay, I only have 3 thumbs up, which means everybody else has no idea what's going on. There we go. Thank you. Thank you. I'm getting some more. That's much better, ne? Much better. Okay, now let's go to Londeka's method. Okay, so now we figured out that we have 8 parts in total. So then Sharp is going to get 64,000. What? Sharp is going to get 5/8. Remember, they are eighths now, ne? And we just established that Sharp gets 5 of them. And West gets 3 of them. Right? So Sharp gets 3/8 of 64,000. Off is what operation, but guys? If I say off, it is multiplication. Okay, so Sharp gets 5 out of 8 of the 64,000, which means West is going to get 3/8 of the 64,000. And I promise you, if you do this, you're going to get the exact same answers. You just use the method you like better. All right. If you've been doing ratios for a while, if you're very confident with them, you will probably use this one. But if you're still unsure, just stick to making them 1. If you know what one part is worth, guys, you will literally be able to work out anything. Okay. Wonderful. Let's get moving. Let's divide 72 in the ratio 3:4:5. What do I have to do first? The first thing I have to do before multiplying and all of that, I have a ratio, so I have to add the ratio, right? It's going to be 3 plus 4 plus 5, which gives me 12. Okay, now let's divide 72. When I first say 72 divided by 12, and this will help me get my one part. What's 72 divided by 12? 72 divided by 12. Is anybody home? 6. So the first person will get 3 of those. The second one gets 4 of them. And the last one gets 5 of them. So the first one will then get 18. My second one will get 24, and my last one will get 30. If you are not sure about your calculation, you just add them all back up, and you have to get 72. If you do not get 72, then you did something wrong in your calculation. All right. Yes, Tlali? Let me unmute you. There we go.
I wanted to ask, ma'am, is it still okay if you add the three ratios together and then put it in different parts, or does that work in a different kind of ratio?
What do you mean?
Like you add 3 plus 4 plus 5, then
Okay,
when you get
12.
and then when you get 12, then you say 3 over 12 is
Or
to
like
4
this.
over 12 is to 5 over
Oh,
12.
yeah, that's fine. That's fine if you want to remind yourself of the parts that everyone gets. Yes,
Ma'am,
that's
how do you solve it further?
so. What you mean is after I do this, I must then say this one gets 3 out of 12, this one gets 4 out of 12, and this one gets 5 out of 12, right? So then you're going to say, initially I have 72, and I'm going to times it by the first one who gets 3 out of 12 of that 72 of is my multiplication sign that we see over here. And this is going to still give you 18. And the second one is going to get 72 times 4 over 12. And my last one is going to get 72 times 5 over 12. And that'll give you the exact same answers. Did I answer your question, Tlali? Hopefully I did. Wonderful. Okay, so you guys can use either method over here, all right? Okay, I want to go to this one. Interesting one, this one. The perimeter of a rectangle is 280 meters, and the ratio of its length to breadth is 5 to 2. Does that mean the length is 5 and the breadth is 2 meters? Is the length of this rectangle 5 meters and the breadth 2 meters? No, that's just a ratio. Okay, so if I knew one of the sides, let's say I knew that the length was 10, then I knew that I was going to times both of these by 2, right? But now I don't know. So what do we do when we don't know in math, guys? If I don't know a number, if I don't know what I'm multiplying by, what do? I put x. Beautiful. So then I'm going to say 5 times x is the length, and 2 times x is the breadth. Before I go any further, did I lose anyone in this step? Before I go any further, do you understand why I put 5x and 2x as the length and the breadth? Maybe I should write you in the beginning. L equals and B equals. I see 2 people saying no. Who wants to talk to me? One of you raise your hands, please, so we can talk. So I can walk you through it and help you understand why I put 2x and 5x. Okay, it's fine. Tlali has volunteered. Yes, Tlali, hello.
Ma'am, I'm confused on how you got the X.
Okay, listen here, Tlali. So the length or the size of the length is not 5 meters. Do you agree with me?
Yes, ma'am.
And the breadth is not 2 meters. Do you agree with me?
Yes, ma'am.
Let's say we knew the length and breadth, okay? Let's say this was 20. The length was 20. Then I would know that I go from my ratio. How much do I have to multiply by to get to 20?
4.
I would have had to multiply by 4. But in a ratio, we said what you do on the left, you have to go do on the right. Do you remember?
Yes, ma'am.
So I would then multiply by 4 on this side, and then that will tell me that my breadth is how much? What's 2 times 4?
8.
8. Now, Kale, do we know how much we are multiplying over here?
No,
We don't. And in math, if we don't know what this number is supposed to be, what do we usually use here?
a variable.
A variable. Do you see where that x comes from? So I said 5
Yes, ma'am.
times x will give me my length, and 2 times x will give me my breadth. Are you sort of getting it now?
Yes, ma'am. Does it always have to be X?
No, you can absolutely use any variable.
Thank you, ma'am.
You're welcome. So guys, the reason we have to use a variable in this case, if they had given us, you're welcome, Londek, if they'd given us one of the sides, we would not have had to do that, right? If they gave us this ratio like this, and they told us that the breadth was 40, we would not have needed x, because I would know for sure that I have to times by 2 this side and times by 2 this side. But now I have no idea what I have to times by over here. So because of that, I'm going to say 5 times whatever that number is. So I put an x. And on the other side, 2 times that same number, which is x. Because what we do on the left in a ratio, we have to go do on the right. Okay, so now we have established that my length is 5x and my breadth is 2x. Okay, how do I work out perimeter, guys? Give me my formula for perimeter of a rectangle. Perimeter, not area, be careful. But we're going to need that area one soon, so I'm going to write it here. Oh, yes, I add all of the sides, but there's how many of each side? Is it just 5x plus 2x? No, there aren't just two sides, guys. Nice, 2 lengths. So it's 2 times 5x plus 2 times the breadth, which is 2x. Okay. What is 2 times 5x, beautiful people? 10x plus 2 times 2x, 4x. Okay, is there anything else we can do here? Over here? I have a 10x plus 4x. Yes, because they are like terms. Right, what's 10x plus 4x? 14x. Now, we already know our perimeter, guys. How much is the perimeter? How much is the exact perimeter? They already told us the perimeter. 280. You guys mustn't neglect the question. They give information. So instead of perimeter here, I can substitute it with 280. So I know that 280 is equal to 14x. And I want to work out this x. So how am I going to do that? Divide by 14 on both sides. Therefore, my x is equal to 20. Now, is the x the length or the breadth? No. X is x. What do we have to do to find the length and the breadth? I'm looking for a secret word that starts with S. Special word. What am I going to do with x equals 20? I substitute. That's true. So then my length equals 5 times x, which means it's 5 times 20. So how long is my length? 5 times 20, and that's going to give us 100. And my breadth was 2 times 20, which means my breadth is 40 meters. We're not done. They asked us for the area. If you guys are not sure and you want to check, you can go substitute this in and check if your perimeter is in fact 280, right? Because it's going to be 100 plus 100, which is 200, plus 40, which is 240, plus another 40, which is 280. So we're done. But now we want the area. We said area is length times breadth, which means 100 times 440, 100 times 40. So then my area for this specific rectangle is 4,000 what? We were given units in the beginning. 4,000 meters area. Meters squared. Beautiful. Okay, this was a very nice problem solving question. Thumbs up, thumbs down on this question. Did you guys all understand what happened here? Nice. Nice, nice, guys. I would have loved more thumbs up, but it's fine. I'll take what I can get. Okay, let's check. Tangi makes a fruit salad for breakfast at a restaurant. She uses the pieces of fruit in the following ratio. A banana, I'm going to color code them so that we know what belongs to what. The banana is 1 to apple, which is 2 to pawpaw, which is 3. Okay. Number 1 says if she uses 20 pieces of apple, so now they're telling us how much she uses. Okay, I'm going to rewrite my original ratio here. 1 to 2 to 3. They're telling us that there are 20 apples. And now we want to know these two. Bear in mind what I just said now, right? To go from one ratio to the next, you have to do the same thing to all of them. Now, how did I get from 2 to 20? How did I get from 2 to 20? I have to multiply by 10, which means I have to multiply all of them by 10, because what you do on one side of the ratio, you have to do it everywhere. So then that means how many bananas does she need? 10. Nice, Roleboa. And Popo, she needs 30. Done. Okay. The next one says if she uses 12 pieces of banana, how many pieces of apple and pawpaw should she use? 1 to 2 to 3. This time we know banana is 12, but these two we don't know. What are we multiplying by in this case? I went from 1 and I went to 12. I need 12. Okay, so then that means how many apples do we need? Nice, guys. And how many pawpaws do we need? 36. Okay, so I want you guys to be a little bit careful here, nah? The question is asking you how many pieces of each thing does she need or does she use? If you give that answer as a ratio like most of you are doing now, your teacher might not give you that mark. Okay, you must go and do the calculations here and say, I need 24 apples and 36 pawpaw. All right. If you write random numbers here, like in a ratio, that might be a little bit of a problem. I will personally mark it right, but I've seen cases when it becomes a bit of a problem if you don't write exactly what you're saying. Okay. All right. Beautiful. It's 10 to... Yeah. Okay, it's fine. Let's do our brain break. Let's do our brain break. Is there anyone who wants to participate for the brain break? Londeka, there we go. Hi, Londeka.
Hi, ma'am.
You want to solve this with me?
Yeah, can I please try?
Let's get going. Okay, first one, cool face plus cool face plus cool face is 15. So how much is one
5.
cool face? One cool
5.
face is 5. Nice. Okay, so it's 5, 5, 5. That means everywhere I see a cool face, I can put what?
5.
Done. Okay. Next one says cool face plus crying face is 9. So how much is crying face?
4. Oh, 2. Sorry, 2.
It is 2. Almost got you there. So everywhere I see crying face, I'm gonna write it 2. Next one. Cool face, a silly face, plus crying face is 11. So how much is silly face?
5.
Let's see.
No,
5,
4.
6,
It's
7.
4.
Yes, it's 4. Beautiful. So this is 4. Now we have a problem here. This crying face is half. Do you see that?
Yeah, I see that.
So then how much is the half of a crying face?
It's going to be 1.
1. Okay, let's see. So then we have 5 plus 1 times 4. How much is that?
6 times 4.
Board mess.
18. Isn't it
Board mess.
24?
Board mess.
Oh, see,
Where do you start?
it's going to be 4. 1 times 4, which is going to be 4. And then 4 plus 5 is going to be 9.
Nice. A 9. Beautiful. Beautiful, beautiful. I had a lot of final answers, but you know, it is what it is, guys. The correct answer is 9. Okay. Next one. That was just the warm-up for your brain break, ne? Using only addition, add 8 eights, add 8 eights to get the number 1,000. It's here. Only addition. 8 eights. You need 8 eights. What are we saying, guys? Londek, are you still answering? Your hand is still up. Awfully quiet, guys. Anybody? Addition and 8 eighths. And we want a sum of 1,000. Hi, book guys. Anyone? No one. Guys, you must use the digit 8 times, and you must add a bunch of times, and the sum must be 1,000. But it can be any number that has 8. So it could be 88 or 8,888. Do you understand what it means? But there has to be 8 of them in the sum. I told you the other one was a warm-up. Let's get going, guys. Let's get going. So it can be any number made with just 8s. And you must be plussing them, and they must add up to 1,000. Let's hear. Nobody? Is anybody who's close to answering before I ruin it and tell you guys the answer? Oh, okay. Kali says I must wait. Okay, I'm waiting. I'm waiting. I'm gonna give you guys a limit. Oh, Senyani has his hand up. Hello. Can I?
Ma'am, it's impossible with 8 8. I did it with 9. 3,
9. Okay,
10.
let's hear.
I did 888 plus 88 plus 8 plus 8 plus 8 plus 8 plus 8 plus 8.
3, 4, 5, 6, 7, 8. That's 8 eights.
Oh, I counted wrong.
That's the answer. Beautiful.